Assalamualaikum warahmatullahi wabarakatuh. In this video, we will be discussing on the rules of indices. The first rule that I'm going to introduce is called the zero index. Zero index means that any base with power 0 is always equal to 1. For example, here I have m to the power of 0. This is equal to 1. The same goes with 4 to the power of 0. 4 is the base and 0 is the power. This is equal to 1. The next one is negative index. Now, negative index means reciprocal. Yes, that is a very big word. I'm going to write it down and explain that word first for you. The word is reciprocal. Reciprocal means 1 over something. So when we have a to the power of minus m, we can write this down as its reciprocal, that is 1 over a to the power of m. So let's see the example here. In this example, we have a to the power of minus 3. So the reciprocal of that is 1 over a to the power of 3. On the next one, we have 3 to the power of minus 2. Since the base 3 has negative index, minus 2, this is equal to its reciprocal, which is 1 over 3 to the power of 2. And if we calculate this is equal to 1 over 9. The third one is fractional index. When the power is in fraction, for example here 1 over n, this will become its root. So here we have a to the power of 1 over n. This is equal to the nth root of a. Let's look at the example here. We have the square root of y. So to write this in an index form, y as the base, and we see 2 as its root. So we can write the power as y to the power of 1 over 2. Let's see if you can get the next one correct. You can pause here to figure it out first. I'm going to proceed with the answer. So it's 7 to the power of 1 over 3. 7 is the base with fractional power 1 over 3. Therefore, we can write this as the cube root of 7. Let's proceed to the next slide. Before I proceed with the next rule, you need to remember that the rules of indices can only be applied on the same base. So, the fourth rule, here I have a to the power of m multiplied by a to the power of n. This is equal to a to the power of m plus n. You can ask your lecturers in tutorial classes to prove this rule for you. Look at the example here. I have x to the power of 3 multiplied by x to the power of 4. Since the bases are equal, so this will become x to the power of 3 plus 4. And this is equal to x to the power of 7. I'm going to leave the second example here for you to do. The next rule is when we have a to the power of m divided by a to the power of n. And this is equal to a to the power of m minus n. Again, you can ask your tutorial lecturer to prove this one for you. So in the example here, I have x to the power of 8 divided by x to the power of 4. So according to this rule, I can write this as x to the power of 8 minus 4. And this is equals to x to the power of 4. Number 6. When I have a to the power of m and the whole thing to the power of n, this will become a to the power of m multiplied by n. Therefore, for this example here, I have x to the power of 3 and the whole thing to the power of 5. This will equal to x to the power of 3 times 5. So this is x to the power of 15. You can pause the video here if you need more time to find the answers for the second example here. Let's check your answers. The first one is 2 to the power of 10. The second one is 5 to the power of 7. And the last one is 4 to the power of 3 over 2. I hope you got it all right. You can high five your friend next to you. Don't forget your hand sanitizer though. Okay, so the last two rules is for us to know when to distribute the power. Since the definition of an index is from multiplication, that means only multiplication and division will be affected. This also means you cannot distribute power if the operation is plus or minus. So, if you have a multiplied by b and all this to the power of m, you can distribute its power So it'll be a to the power of m, b to the power of m. Look at the example here. You have x multiplied by y to the power of 5. Because the operation for x and y is multiplication, we can distribute its power to become x to the power of 5 and y to the power of 5. The same goes for the next one. Because its operation is division, here too, we can distribute its power. So in the example here, we have w divided by z. So you can distribute its power to become w to the power of 4 over z to the power of 4. You can pause here to take some time to answer these two examples. Let's check. The first one is 2 to the power of 4, w to the power of 4, and z to the power of 4. If you calculate this, you should get 16 w to the power of 4, z to the power of 4. The next one would be 4 to the power of 3 divided by 7 to the power of 3. If you calculate this, you should get 64 over 343. So that's it for the definition and the rules of indices. If you are still confused or has any questions, you can watch the video again or you can ask your lecturers during your tutorial sessions. You can also ask your question on the comment section below. We will try to clear your confusion as soon as we can. The next video will explain these two questions. Make sure to answer them first before you check your answers and understanding on this subtopic. Thank you for your attention. See you on the next video. Take care and goodbye.